So you're taking Viva?
Not, yeah, I'll take this week. Okay. So this is the setup for measuring the emissivity of a surface, right? Touch surface, right? So there is an enclosure in which two surfaces are there. So one is the black surface and another is the test surface for which you want to find out the emissivity, right? So what is emissivity? So emissivity is the ratio of the emissive power of that surface with respect to the emissive power of the black surface, right? So black surface is the one which emit maximum radiation and which will absorb all the radiation which is incident upon that, right? So the emissivity of the black light is 1. So with respect to that, what is the emissivity of the test plate? So that's what you are going to measure during this experiment, right? So the procedure is like this. So basically you need to set separate voltages for the black plate as well as the test plate. So for example, since the black plate does more work, that means it emits maximum, it absorbs maximum, right? We need to give more input to the black plate. So what we are doing is, we are just setting a voltage of around 52 for the black plate, right? And so maybe 50 for the test plate, right? So the voltage can be, so this is the voltage setting for the black plate and this is the voltage setting for the test plate, right? So you can test the voltage, let's say you want to set it, this is, yeah, so you can, if you want to measure the voltage of the black plate, you just, so there is a, yeah, so this gives me the voltage of the black plate as well as the current of the black plate. So the black plate I am setting a voltage of around 52, right? Yes. So the black plate voltage is set as 52, right? And this ammeter shows what is the current that is flowing through the black plate. So that means I can find out what is the power input to the black plate. So that is VI, voltage multiplied by the current will give you the power input to the black plate, right? So next we have to set the voltage of the test plate, right? So test plate actually emits less, right? So it does less work. So we are setting around, let us say 2 to 3 voltages lesser than that. So that means, let us say I'm setting a voltage of 50 for the test plate, right? So this gives you the voltmeter reading for the test plate. So this gives you the what is the current flowing in the test plate. So now the setting is done, right? Now we have to wait for both the surfaces to reach the steady state temperature. So there are temperature sensors are there which is mounted on the plates. That means there are 3 sensors are there for the black plate and 3 sensors are there for the test plate, right? So these temperatures can be found out with the help of this digital temperature indicator, right? So right now it shows the temperature T1. So by pressing the buttons here, so I can note down the temperatures of the different surface, I mean different thermocouples, right? So this now T2, so T3, T4, T5, T6, right? So T1, T2, T3 corresponds to the black plate and T4, T5, T6 corresponds to the test plate. And of course T7 would give you the ambient temperature, right? So what we suggest is you just keep the temperature at a particular level, let us say T1, right? T1, and wait for that temperature to become steady, right? So once that temperature, there is no variation even after 5 minutes, right? So then we assume that all the temperatures have become steady and now we can take the readings. T1, T2, T3, T4, T5, T6, right? So then one set of experiment is over. One set of readings are over. right? So if you want to take set another voltage and take another set of readings, let us say 60, right? So then keep for the test plate a voltage of 60 volts and keep, let us say, around 2 volts greater than 60, that is 62 for the black plate, and repeat the same procedure. So you have to wait any one of the temperature T1 to become steady. So it may take around 10 to 15 minutes, right? Even more than that also. You just wait, right? Once the temperature becomes steady only, you get some good readings and your results would be more closer to the actual values, right? That's it.